Hi everyone, welcome to week 3. This week we'll cover 6 items. First, we'll list the key factors for effectively leveraging data analytics. Then we'll analyze high quality data. We'll then describe enterprise orientation. Then we'll outline analytical leadership, and finally explain strategic targets and analytical talent. Thank you so much. Hello again. This is week 3 of business data analysis and modeling. This week we're focusing on the effective use of analytics. First, the learning objectives again are listed here. Just to review, looking at the key factors for effectively leveraging data analytics, looking at high quality data, describing an enterprise orientation. We'll get that from Davenport. We'll outline analytical leadership, explain strategic targets, and evaluate analytical talent. To be able to get the best use of data is very important that there's very high level of quality in the data. You know, data processing is what? Data in, process, and data out. If the data itself is not standardized, is not verified, is inaccurate, or any other anomalies, then the quality and effectiveness of any decisions that are made or any interpretation of that data will be adversely affected. There are 8 different areas of quality techniques that are described here, but there are more depending on the specific industry and the type of data analysis that's being done. Throw another dimension in terms of different formats of data, different sources, then you have a very potentially complicated challenge to maintain quality. And then not to mention, as we have in previous sessions, you know, the relevancy of data and so forth. There are other things that need to be looked at, but all of these things need to be looked at in order to get the best use of data analytics. Davenport in his book, Competing on Analytics, uses the following definition. He says it's the extensive use of data, statistical and quantitative analysis, explanatory and predictive models, and fact-based management to drive decisions and actions. And in his book, he describes how more and more data analysis is becoming part of the core competency of the firm today, not just in managing its operations and seeing how effective they are deploying staff, executing against cost models, etc., but also in terms of looking at potential strategies of business going forward, and even doing some scenario planning or scenario analysis, doing things that are prescriptive to be able to see what are the best situations and best management decisions that can be made to move the company in a much better and more competitive area. This slide shows very clearly that the best performing companies use analytics better and more than their competition. And that would be from their financial performance to making faster decisions, to making more effective decisions and executing them well, and actually making very frequent decisions. And what does that mean? It means that the companies are able to diagnose or figure out what's happening and make adjustments, based on, again, data and factual analysis better than their competition. And they're seeing the financial results to match their performance. Another framework actually comes from Deloitte Consulting, and it shows kind of the evolution of the use of data analytics in stages. So the first stage is to achieve data quality, very good, highly accurate and complete and pristine data quality. Then being able to figure out what happened in the past, or descriptive analysis. In descriptive statistics, you would look at things, very basic things within the data, such as what's the mean, what's the mode, what's the dispersion of the data, or the spread of the data, those kinds of things. You just know what happened. the third stage is to know why it happened, or to do a little bit of a root cause analysis, if you will, to be able to understand what are the drivers or the key reasons why things happened. The fourth stage is to examine trends, or to be able to take a step back and say, is there a pattern in what's happened in the past? And then the next step is then take that pattern analysis and derive insights to see what different decisions would I make, or what adjustments would I make to my business to achieve even better results. So for example, you might come up with 3 different scenarios, 3 different adjustments in operations, if you will, to try and cut costs and achieve a more effective result. And you'll be able to use predictive analytics to come up with the best of, say, like 3 scenarios. And lastly, the highest level is what's called semantic analysis. It's actually more ambiguous, but it's more of an intelligence to be able to discern the meaning of things. An example of that recently was when Nike released the new LeBron James tennis shoe, and analysts were able to look at unstructured Twitter responses that are out there to determine the general sentiment, if you will, of consumers. What were they saying? What were their reactions? To be able to use word proximity and associations to understand from an intelligence standpoint what's really going on out there in the populace. So that's the highest level of analysis. All the time is, what's an algorithm? So an algorithm is a set of steps that results in a calculation, a processing of data. This algorithm that's displayed here is what's called Euclid's algorithm for the greatest common divisor of 2 numbers. And so these are the steps that you would put into a programming language or in an Excel spreadsheet. If you have the numeric values as input to the actual calculations, then you end up at the end with a result. Another definition of an algorithm is it's a type of process that you do. For example, there's something called cluster analysis, where you take a scattering of data points and you try to see if there are different concentrations of values along an X and Y axis. So the steps used there in a statistical package, the total set of steps would be considered an algorithm. So you start from step 1 through whatever number of steps, and you end up with a cluster analysis. Usually a graph is what's displayed in. Another kind of algorithm is linear regression. There are different kinds of regressions, but this example that's being shown here is taking a set of scatter points, or data points that are scattered, again across the X and Y axis, and trying to fit them to a line, something that's very, very clear and understood. The line, as you can see, cannot capture every data point, but it's the most accurate depiction of those points. And if you were to put a formula together for that line, it'll be an y equals ax plus c kind of line, which we all saw in beginning algebra. Many times it'll be a polynomial or something like that, which means there's many different independent variables on the right side of the equation. When added up, plus a constant will equal the dependent variable. So that's basically what a linear regression is. The uses of analytics, and from very basic to the most advanced. And this is just another construct towards that ends. So in the lower part, it's all just descriptive analytics. If you go into Excel, you highlight a column of numeric values. There's a function in the data analysis add-on module where you can say, give me descriptive statistics. And what that does is just tells you, just tell me what's going on with the data. What's the average value? What's the mean? What is the mode, the most frequently occurring value in that stream of numeric values? What is the dispersion or the scattering of those values? So very basic description statistically of the data. And then above that, of course, are the bigger and more complicated analytics. We had talked earlier about prescriptive analytics and predictive. Predictive actually is a step before prescriptive. Predictive analytics says, if I understand the patterns in the past, I can then plot those patterns consistently going forward and make predictions. For example, prescriptive analytics says that I can take past data and predictive data and be able to come up with 1, 2, 3 or more scenarios where I'm changing one factor to see what the end result would be, so that I may make a decision that will optimize the company's results. And so as we go up, we're able to look more future focused and look at scenarios and pick the best one for the business. Davenport postulates that there's 5 levels of analytical capability. Quite simply, stage 1 basically are the majority of companies that don't use analytics at all. Stage 2 says they have analytics, but they're very, very internal to the firm or localized. Stage 3 is at least they're thinking about, okay, can I get to predictive and prescriptive, or at least higher level. And then stage 4 are companies that use analytics just on the day-to-day operations. And then stage 5 are those that are able to look strategically out far enough to use analytics to outmaneuver and beat the competition. And just as the pyramid depicts, the number of companies in each of these levels actually gets smaller as you go up in sophistication. Again from Davenport, and in it, each letter of delta, these are differentiators, if you will. One is data, the other is enterprise view. In other words, the entire business is managing using analytics. Leadership, which is committed to the use of analytics, both operationally and strategically. The targets, in other words, we are very specific in what we're trying to achieve as a business, and we have targeted use of specific analytics or pools of data. And so it's not just random, it's something very, very deliberate and by design. And the last point is we have a pool of resources that are very good at using analytics. Here they talk about professionals and amateurs. So actually having the talent within the firm or access to it is a key in the Delta framework. So this is again from Davenport, and in it he talks about 5 different strategies for using analytics. So it maps very much to the 5 layers of the triangle that we talked about earlier. The lower levels, or level 5, is just persevering through analytics. It means just surviving, keeping your head above water in a very competitive world, using your analytics that are available to you, mostly local. And then revenue through analytics, and this is, I would say, big focus on marketing analytics or marketing campaign kinds of analytics, and in other words, being able to drive revenue through those things, drive sales. And then improving with analytics, this is again looking at an enterprise view where we're able to measure the performance of every department of a business as well as collectively, and it's a culture of using fact-based decisions and based on very robust analytics across the entire enterprise. Then competing with analytics basically says that the business itself is looking at business processes and the performance and the resulting data and analyzing that data to be able to improve their standing against competition. So competing with analytics. And then the top level is competing on analytics, and it's basically using analytics as a key competitive advantage. So that's saying that analytics is a very fundamental part of the core competencies of the firm, and they're using them both operationally and strategically to achieve their ends and to compete against others that do use analytics as well. 5 firms, along those the same 5 levels, and it looks like the vast majority of the use of analytics is really the incremental or improving with analytics, trying to improve the operations, kind of looking within the firm and saying how can we be a little bit more effective or efficient in what we do. The higher end obviously is a smaller piece of the pie. In other words, those firms that actually compete on analytics, again, is a small portion compared to the rest. So with this, we're going to start looking at are some of the key data analysis and data science trends that are out there. The first one is the man-machine dichotomy is blurring. In other words, smart machines and smart people are able to collaborate with smart machines to achieve a better result. And it used to be kind of separated machines from people and so forth, but now those things are coming together, and smart people being able to collaborate with those tools is actually part of that whole competing on analytics. They talk about what cognitive technologies is doing and how much is going to be invested in it. It looks like quite a bit of money between now and 2025. Also, analytics, as we mentioned earlier, is expanding to be used in every part of the business like never before. So everyone's heard of big data, and something like 97% of all firms are looking, if they haven't already implemented it, they're looking to expand what they're doing with it to achieve better outcomes, or to stay afloat, if you will. Cybersecurity uses analytics not just to detect security breaches and fraud, but also to prevent them. And so real time, as various parties interact with IT infrastructure, applications, and systems, cybersecurity is using analytics to interpret what's happening and to mitigate risks out there. An example of that would be what you have happen with your credit card. Certain transactions, if they tend to be outside of the norm, immediately cause the card to be suspended and not able to be used. Those kinds of things are a manifestation of this, growing cybersecurity infrastructure that's in place. The Internet of Things is basically saying that just about everything now is on the internet, and because of that, there's so much data out there. Real-time data being produced by so many different devices, and whether they're just kind of autonomous and sitting on the internet like your home refrigerator nowadays, or smart devices, but everything is on the internet. And so analytics is necessary to make sure those things operate as expected in helping people to improve their lives. There's a growing gap between the number of open positions for data scientists or deep analytics folks and the pool of talent. There's an increasing number of programs focused on these areas, but they can't keep up with the demand for them. There's just not enough people today, and the gap is widening as we speak. The last dynamic that's occurring is that businesses, because of the use of data and data analytics, are becoming like the sciences. In other words, more fact-based and not based on intuition or past experience or anecdotal kinds of things. They're actually able to use real-time data to measure the effect of their decisions in real time, like never before, and use the scientific method. In other words, come up with hypotheses and then test those hypotheses based on the available data, not just internal data, but also in combination with or maybe just external data. So here are some examples of analytic models that have been played out and very, very successful. And you can read those, customer, frontline systems customer, the United States Air Force Logistics Center. They handle, many, many, many millions of tons of military personnel and cargo. And they're using analytics. They're able to model and simulate and optimize, saving the taxpayers many millions of dollars and saving lives. And then, of course, there's the Sloan Kettering Cancer Center, where they're looking at cancer treatment and effective medicines. Quick slide to show how this use of data analytics can help your work or your career. And again, the applications are expanding every day, as well as the demand for that for these critical skills. So we've seen, as I mentioned, a huge growth in demand for data science talent. There is no standard definition of what a data scientist is. It can be anything from someone who has a master's or PhD in mathematics or applied mathematics, to many other to statistics. Masters or PhD in statistics. It could be someone who has used all the tools in their PhD or master's research. But here are some of the specific areas and some hybrids. Some of your computer science folks, like your Hadoop programmers and all, are very, very deep in these skills. And science is used for drug discovery and many other applications and so forth. So this is an emerging area that there's lots and lots of opportunities and will continue to be so. So here's some use cases for big data. You can see them. Social media analytics. I mentioned the LeBron James tennis shoe. That's a social media analytics application. Listening to the voice of the customer and using specific voice-driven input to route a caller to the very best person in the call center. That could be based on language. It could be based on the demeanor of the caller. It could be based on their product or service that they're calling about, and all those kinds of things. eBay's a major online kind of retail through bids application, and they're using Hadoop and MapReduce and statistical analysis to try and improve what their customers experience and to put the best products and services online in their environment. General Electric is using big data. They're hiring like 400 data scientists, mainly for financial and marketing applications. On the financial side, GE Finance is one of the biggest financial institutions in the country, and obviously they use data analytics to assess risk for prospective borrowers, and also they use data analysis or analytics to be able to figure out who to market their services and goods to. So all of that, again, is to improve the bottom line for General Electric. EMC is a technology infrastructure company, and they have a big data appliance, product that they purchased, and they're competing against Teradata and Oracle and a lot of other kind of big data vendors, either software or hardware, and they're again hiring many data scientists for this. Quid, as in quid pro quo, but the name of the company is called quid.com. It's a data visualization offering that uses plot diagrams to be able to show visually what's happening. They do a lot in biopharma and social media and so forth. That little display doesn't do us justice in terms of the applications and the brilliant illustrations or visualizations that they're able to produce with their tool. Saying those are the two types of data out there. This framework shows the difference between the two in terms of focus, relationships, and technologies. So think of small data as more the traditional kind of business intelligence set of tools, and then big data are the newer ones like the Hadoop and Python and those kinds of things, right? So I mentioned earlier about data quality, and this is again super important. It's worth bringing it up again. Data is very important that it has the following kinds of attributes. It's accessible, that it's accurate, that there's a presentation that actually depicts it in a way that's meaningful and allows for appropriate interpretation, that you have complete data, that in other words you have all the attributes that are necessary for business decisions or analysis, and so forth. All these things are very important. So this area of data science or data analytics is actually a plethora of disciplines. In fact, they have some overlapping terms, which again we get from the Nesbitt book. So we mentioned business intelligence and then statistics, and data mining is kind of the newer area. Forecasting, is also kind of a newer area. And then operations research probably is one of the older areas. But you can see that, having the right skills or the right solution sometimes is a combination of, two or more of these areas in order to get the right kind of algorithm. So in other words, the right kind of analysis for you to be able to make the best decisions or to diagnose what's going on with your business. Is a reality, and it's an expanding one, and it's really there's more companies trying to get folks in that have this skill, and the positions are far outweighing the number of people that have it. So this is definitely an area that you want to try to explore if you're interested.